degrees. And the relationship between radians and degrees is that there are pi radians in 180 degrees. So the unit multiplier is still the same. It's just now instead of 180 being at the bottom, now it's at the top. Because what I want to cancel here is this pi radian. And it does. Because pi divided by itself cancels and radian divided by radian cancels. And so to put this in degree mode, that's 360 degrees divided by 3, which is equal to what? 120 degrees. Now let's go back to our circle where we have everything labeled. This is 90, right? This was an extra 30, which is 2 pi over 3. What did we just convert? 2 pi over 3. We said was 120. What's 90 plus 30? 120. Okay? So we're simply going from either a length to an actual angle measure, or from an angle measure to the length of the circle, or the portion of the circumference that it represents. All right, I want you to convert these measures real quick. We're going to first convert 3 degrees into radians, and then we're going to do the other way, and then we're going to do some graphing. Convert the degrees to radians. And the process is going to be the same for all 3 of them. You're going to write the unit multiplier the same exact way for all 3 of them. In each one of these, the unit multiplier was pi radian over 180 degrees. Why did I choose to put 180 in the denominator? I'm trying to get rid of the symbol degree. I'm getting out of degrees. And in each of these cases, if you've got degrees in the numerator and degrees in the denominator, they cancel each other. And so to finish it off, all you've got to do is reduce 150 over 180. Yes? No, we're not going to be doing decimals. You just reduce it and leave it as a fraction. All right, so if this is 150 pi over 180, you need to reduce. 10 goes into both of them, and then 3 goes into each of them. So this would be 5 pi over 6 radians. This is 290 pi over 180. 10 goes into 290 and 180, and that's it. 29 is a prime number. So this would be 29 pi over 18 radians. Here we have 390 pi over 180. And 3 goes into 39 and 18. And it would be 13 pi over 6 radians. Okay, so there's a whole lot of explanation for you to get to this point. But I wanted you to understand how a unit multiplier works and what the relationship is between the degree measure and the radian measure. Again, which tool would you use if I said to draw something at, 250 degrees? A protractor or a ruler? A protractor. If you wanted to actually find the physical distance of that piece of the circle, what would you have to use? A ruler, which would be radian measures. Okay? Now we're going to convert from radians to degrees.
No, that's what
Well, what are you trying to get out of?
the other part.
The radian part. So the radian part of the unit multiplier goes in the bottom.
Yeah, but it's pi. It's just pi.
Pi radian. 180 is your degree part.
I don't know what's the number to put in.
180 degrees, pi radian. What cancels in all of these? Pi radian. Pi radian, pi radian. And the only measure you have left showing is a degree measure. So the rest is simply multiply it out and divide. And you can put that as a decimal. Degrees can be put as decimals, so you could actually do that on your calculator. 5 times 180 over 7. What's 5 times 180 divided by 7? Say it loud, say it proud. All right, and then we'll round. Now, if you were asked to graph these 3 angles, what's the difference between the first 2 and the last one? No, the direction you take off in. Okay? We always start at the initial side, which would be the x-axis going in the positive direction. And we're going to go up and around to get to 128.6 degrees, up and around to get to 720, or down and coming back the other way for this last one of negative 72 degrees.
So we're going to be using protractors for the next test?
Yes. Okay, now, notice we had a 720 degree angle. Well, how do you graph a 720 degree angle if a circle is just 360 degrees?
Go like over 2 circles.
Starting from your initial side, because it's a positive angle, we need to go in this direction, and we need to keep going in circles until we hit 720 degrees. So as we come around through this, that's 90, that's 180, that's 270, that's 360, that's another 90, that's another 180, that's another 270, that's 720 degrees. And that's how you would graph a 720 degree angle.